For a continuous random variable that follows a normal distribution, calculating probabilities is essentially finding area under the bell curve. So if I'm looking at a question like, what's the probability that my variable has a z-score less than negative 1.23, I start by drawing a sketch of the bell curve, labeling the z-score, and then shading the area to the left, in this case, of the z-score. I'm shading the left-sided area here because that is where the z-score would be smaller than negative 1.23. To find this area, I'm going to use a table of values for the normal distribution. Since I'm looking at a negative z-score here, I need to make sure to find the negative z-score table. And to read this table, I'll start by going down the left column until I find negative 1.2, which matches up with the first two digits of my z-score. I need to pick one of the areas in this row, but to pick the right area, I need to find the column that has a 3 in the hundredths place, since my z-score has a 3 in the hundredths place. So I'll read across the top until I find the column that has 0.03, and then I just need to look at the overlap from the row and the column so that I can read the z-score of negative 1.23. The area is the 0.1093. So for left-sided areas on a normal distribution, all we need to do is find the z-score on the table and then pick out the associated area. To find a probability like z greater than negative 1.2, I'm not going to simply read the z-score and the area from the table. Instead, I have to do a little bit of deduction first. We know the left-sided area for that z-score, and if we looked at the table, that's exactly the area we would pull out. But we're looking for the right-sided area. In order to find the right-sided area using the table, I'm going to have to first find the left-sided area, and then recognize that the total area, left and right combined, is equal to 1. So if I start with all of the area, 100% of the area, and I subtract the left-sided area, I will find exactly what I'm looking for. We can't read this directly from the table though, because notice this table shows the cumulative areas from the left in the standard normal distribution, and again we're looking for the area on the right. So we're going to use that idea, 1 minus the left-sided area, to find the right-sided area. We happen to know the left-sided area since we just calculated it, so we'll do the difference of 1 minus 0.1093 to find the right-sided area is almost 89%. So again, we just found probabilities using areas. So for our first question, which involved left-sided area, we found the probability that a variable value has a z-score less than negative 1.23. That was about 11%. And for our second question, what's the probability that our variable has a z-score greater than negative 1.23? We found that was about 89%. Let's try a slightly more challenging question. If we wanted to know the probability for a variable value having a z-score between two numbers, we're going to need to do this in multiple steps. So first, of course, draw our diagram. So I have the bell curve and I put the two z-scores that are involved in my probability, and I shade the portion that I'm interested in. So if I want z between those values, I'll shade the area between them. Now this table does not give me area between z-scores, it only gives me area from the left. So I will find the area on the left side of each of those z-scores. We've already calculated the area left of z equals negative 1.23, so we're going to do the next one. Looking at the z-score of 0.87, I'm going to refer to my positive z-score table to find that area. The positive z-score table has basically the same layout as the negative z-score table, but notice that all of the z-values on the left column are positive. To find the area, I'll read the table just like we did on the negative z-score, starting along the left column, looking at that row of areas, and then picking out the appropriate column for my hundredths place digit, and finding the overlap of the row and the column. So the area left of z equals 0.87 is 0.8078. And again, this table is giving me area from the left on the standard normal distribution. So both of these area calculations are left-sided area calculations. Now I have a blue area and I have a purple area, but what I'm interested in is this yellow area. And that yellow area is going to involve both the purple and the blue. So the purple area, that's more than what we want, right? The yellow area is smaller than the purple area because it has that left tail cut off. Well, that left tail that we need to cut off is the blue area. So if we do purple area minus blue area, we'll get exactly what we're looking for, which would be the yellow area. So using those two area calculations that we read from our table, we'll calculate the difference to get our final answer. The probability that our variable has a z-score between negative 1.23 and 0.87 is about 70%. Finding areas, finding probabilities for normal distributions, we have to do a little bit of thinking to figure out, are we reading it directly from the table? Do we have to use the idea of a complement? Are we looking for right-sided area or area in between two values? Pictures are very helpful here. I recommend drawing a diagram for each one of these problems until you really got the hang of what the question's asking.